This question is given in GATE 2014. So watch it. Consider a paging hardware with a TLB, which means they are saying that paging is applied and then TLB is applied. This is given in GATE 2014. Okay. And then they are saying that assume that the entire page table and all the pages are in the physical memory, which means there are no page faults at all. The entire page table is there in the physical memory, as well as all the pages of the process are also in the physical memory. So what is it? There is no concept of virtual memory, or even if there is a concept of virtual memory, everything is present in the main memory. So whenever there is no virtual memory concept, there is no page faults. Page faults arise only when there is virtual memory concept. Because virtual memory says that you can run a process even if you don't have all the pages in the main memory. If you don't have virtual memory, then it definitely means that all the pages are in the main memory, right? And then they are saying that it takes 10 milliseconds to search the TLB. So why do we search the TLB? For the page table entry, and 80 milliseconds to access the physical memory, right? And then if the TLB hit ratio is 0.6, then the effective time is so they are just asking the effective memory access time. So whenever we have TLB involved, effective memory access time you can divide into two parts, right? Effective memory access time you can divide into two parts. One is time taken to convert virtual address to physical address, right? And then after getting the physical address, then the time taken to access, right? Time to access the main memory, isn't it? Now I told you this. So what is the time taken to convert virtual address to physical address? So it is time taken to access the TLB, and in case if there is a miss rate in TLB, right? So let us say miss rate in TLB, I am writing it as TM. Okay, so don't by heart this formula. So TM is the miss rate in TLB. In case if there is a miss rate in TLB, then I have to go into the main memory and search for the page table entry. So how much time will it take for us to search for the page table entry? That depends on the number of levels in the page table, right? And since nothing is given, you can assume that the number of levels is 1. If nothing is given, always the number of levels in page table is 1. But anyway, the formula is k into let us say main memory access time is small m. So what is it? Time taken to access the TLB. In case if it is not in TLB, how do you know it? If it is a miss, right? TM is the miss probability. Then I have to go into the physical memory and I have to access all the levels of the pages. And in order to access one level, time taken is m. And if I have k levels, time taken is k into m. This is time taken to convert virtual address to physical address, this entire part, isn't it? And next thing is you have to go to the main memory and then access the physical address, right? Then if small m is the time taken to access the physical memory, then in case if there is a page fault, right? So let us say the page fault rate is some TPF, page fault. In case if there is a page fault, then I have to go for the page fault service time, isn't it? So this is time taken to access the main memory, and in case if there is a miss in the main memory, which means there is a page fault, then I have to go into the secondary memory and have to get it, right? So for that the time taken is this much page fault rate. Got it? So now one thing is they are saying that there is no page fault at all, which means you need not consider this factor, right? Therefore, and second thing is the levels are not given, therefore k is 1. So what is the final formula? Time taken to access the TLB plus in case if there is a TLB miss, then we have to multiply with the main memory access plus time taken to access the physical memory. And how much is this? So time taken for this is 10 milliseconds is the TLB, and the TLB hit rate is 0.6. Then what is the TLB miss rate? You have to be careful here. This is TLB miss rate. In case if it is not present in TLB, then only we are going to get into the main memory. That is why it is miss rate. Into what is the main memory access time? It is given as 80 plus what is the main memory access time? 80. How much is this? It is 10 plus, I think this is 32 plus 80, right? So I think it is 122 milliseconds, right? Fine, 122 milliseconds is the answer here. 122 milliseconds, right? So if you didn't understand this formula, maybe you can use the other formula as well. So what is the other formula? Effective memory access time is, in case if it is let us say X is the hit, TLB hit. In case if the required byte is present in TLB, the required page table entry, then it is T plus M, right? So in case, because it is just 1 T plus M, in case if it is not present in main, TLB, then it is, you have to find out that it is not present in TLB, and then you have to go into the main memory and you have to get the TLB, that entry, page table entry, and then the main memory also, right? The access the physical memory 2M. So this one and this one, this one both are same. If you want it, you can expand it, and here Tm is nothing but 1 minus x. It is a mix rate is 1 minus x, right? So here I have used the formula 1 minus x. Anyway, when you divide it and simplify it, it will be easy for you to understand instead of writing it in that complex manner. That is why I am using the simplification. Okay, textbooks have this kind of formulas, but then once you simplify it, it will be easy for you to understand. That is why I used it. Okay, so anyway, this is the answer, 122 milliseconds. Fine.